Dear learners, welcome to the new lecture of Engineering Chemistry course series. We are covering the topic green chemistry. In today's video, we will cover the topic principles of green chemistry, in which we will continue the topic use of renewable feedstocks. That is the seventh principle of green chemistry. Next is the eighth principle of green chemistry, that is reduced derivative, and ninth principle of green chemistry, that is catalysis. But before going to today's video, just have the recap of the previous lecture. In our last class, we discussed about the third, fourth, fifth, and sixth principle of green chemistry. The third principle was the less hazardous chemical synthesis. Fourth principle is designing safer chemicals. Fifth is the safer solvent and auxiliaries. And sixth principle of green chemistry was the design for energy efficiency. Now, in today's class, we'll cover the seventh, eighth, and ninth principle of green chemistry. The seventh principle is use of renewable feedstock. Eighth principle is reduce derivatives, and ninth principle is catalysis. So, what is the seventh principle? The seventh principle is the use of renewable feedstock. Basically, what is this principle says? According to this principle, use renewable feedstock whenever possible to reduce environmental impact, conserve non-renewable resources, and promote sustainable chemical production. So, what this principle emphasizes? This principle emphasizes the use of raw materials that are renewable rather than the depleting finite resource like the fossil fuels. That means basically this principle focuses on the use of renewable materials for any chemical process. Secondly, the renewable feedstocks are the materials that can be replenished naturally over a short period of time. Example, plant biomass, agricultural waste, and the microorganisms. That means what are the renewable feedstocks? These are the materials which can generated in the nature by itself. For example, plant materials, agricultural waste, microorganisms, etc. So these are the renewable feedstock which can be used in the chemical processes to save the environment. Now, why it matters? Why the use of renewable feedstock is important? Basically, the non-renewable feedstocks like petroleum, coal, natural gas are limited and contribute to the environmental pollution as well. While using renewable resources reduces the dependency on these finite resources and minimizes ecological impact. That is why we are focusing on the use of renewable feedstocks. Now, the importance of the implementing the seventh principle of green chemistry. Why it is this principle has to be implemented. So, the non-renewable resources like petroleum, coal, gas, natural gas are limited and depleting continuously. We know that the renewable feedstock like biomass, plant, carbon dioxide are sustainable and replenishable. So these helps to reduce greenhouse gas emissions and the global warming. This leads to the cleaner, safe and biodegradable products. This also minimizes the pollution and environmental damage from fossil fuels. It also supports rural economy by using agricultural and the biological resources. It ensures long-term resource availability for future generations. So that is why the implementation of the seventh principle is important. Similarly, the use of biomass based materials like starch, cellulose, vegetable oil, sugars instead of petroleum based raw materials is the best example of the seventh principle of green chemistry. Secondly, Develop biorefineries to convert agricultural waste and plant materials into fuels, chemicals, and polymers. So, by the biorefineries, we can convert the agricultural waste into the useful products. Similarly, we can adopt biotechnological processes such as fermentation and enzyme catalyzed reactions to produce useful chemicals. We can also utilize the carbon dioxide as a renewable carbon source in a chemical synthesis. We know carbon dioxide as a pollutant of many of the reaction. If we can use this carbon dioxide as a renewable carbon source, so this can be very helpful to minimize pollution as well as to create some new chemical with the help of this renewable carbon dioxide. Similarly, design biodegradable and bio-based products like bioplastic. This is the good example. Promote recycling and reuse of materials to reduce dependence on virgin fossil feedstock. Encourage research and innovation in renewable energy and bio-based chemistry. It also how it can be implemented, support local agricultural and industrial integration to create a sustainable supply chain for renewable raw materials. So by these ways, we can implement the seventh principle of green chemistry. Now, the examples of this seventh principle of green chemistry is using plant-based or naturally renewable materials instead of the fossil fuel is the main idea behind the seventh principle of the green chemistry. For example, the plants, for the manufacturing of the bioethanol, sugarcane or corn is used instead of using the petrol. So petrol is the fossil fuel. We can use all sugarcane or the corn as an alternate to this petrol to synthesize the bioethanol. Similarly, the biodiesel can be produced by using the vegetable oil or the waste cooking oil instead of using the diesel or the crude oil. And the bioplastics like polylactic acid can be formed by using the cornstarch instead of the petroleum based plastics. And the paper can also be manufactured by recycled fibers or agricultural waste instead of the cutting new trees. And the biodegradable detergents can also be made by the plant-based oil instead of the synthetic photochemicals. So these all are the examples in which we are using the renewable resources as the raw material to synthesize bioethanol, biodiesel, bioplastic, paper, and biodegradable detergents. Now, coming towards the eighth principle of green chemistry, that is reduced derivatives, it states that unnecessary derivatization, such as the use of blocking groups or protection or deprotection steps, should be minimized or avoided whenever possible because such steps require additional reagents and generate waste. So, to avoid the additional steps in some chemical process, we can save the extra generation of the waste product into the environment. So this principle emphasizes avoiding unnecessary use of derivatives such as protecting groups, blocking groups, or temporary modifications in the chemical synthesis. Each derivatization step often requires extra reagents, solvents, and energy and generates more waste. Therefore, the reactions should be designed to proceed directly without intermediate steps whenever it is possible. So, the importance of implementing the eighth principle is to reduce chemical waste and the byproducts, to save time, energy, and the raw material, to make the process simpler, faster, and more economical. And it also lowers the environmental impact of chemical manufacturing. So these are the importance to implement this eighth principle of the green chemistry. The example of the reduced derivatives, that is the eighth principle, is the direct esterification of acids with the alcohol. Esterification is the process in which acid and alcohol reacts to form the ester. In the traditional method of the organic synthesis of ester, The carboxylic acid is reacted with the acid chloride, which is a derivative, and then this reaction resulted into the formation of an alcohol, and later on with this alcohol reacted with the chloride to react the ester. So basically, in the traditional method to synthesize the ester or the esterification reaction, it involves the two step. First step is the formation of the acid chloride. This is in which acid reacts with the thionyl chloride to form the RCOCl, that means chlorine derivative. And in the second step, esterification step, this chlorine derivative reacts with the alcohol to form the ester. So we can easily see that in this two-step reaction, there are so many reagents formed as a byproduct in the reaction, which are released in the environment as a pollutant. So the problem with this method is it requires toxic and corrosive reagent like thionyl chloride SOCl2, which is toxic. It generates hazardous byproducts like HCl and the sulfur dioxide gases. It involves two separate steps, increasing energy and the material consumption, and produce more chemical waste. So this is the traditional method to synthesize the ester, or we can say this is the traditional method of the esterification reaction. But by using the green chemistry eighth principle, we can synthesize the ester in the single step. How? The direct esterification can be, in the direct esterification, the ester can be synthesized directly by reacting the carboxylic acid with an alcohol in presence of acid catalyst such as the sulfuric acid and the enzyme biocatalyst. So alcohol and acid reacted in presence of acid and the biocatalyst to form the ester in the single step. So what are the advantages of this direct esterification? It avoids formation of the acid chloride. No toxic reagents or byproducts like HCl or SO2 is generated in this reaction. It is simpler and safer process. Higher atom economy, as we can see in this reaction, only H2O molecule released as the byproduct. So atom economy is higher in case of direct esterification reaction. It can be performed under mild catalytic condition using the green catalyst or the biocatalyst as the, or the bioenzymes as the catalyst in this reaction. So by the use of this direct esterification reaction or the green chemistry reaction, we can reduce the derivatives of the chemical reaction. Now, other examples are direct oxidation of alcohols to aldehydes without using protective groups. Second example is using biocatalyst or selective catalyst that target specific functional groups, eliminating the need for protecting steps. Third step is designing one-pot reactions where multiple steps occur in a single reaction vessel. So these are the some example which clearly defines the importance of the eighth principle of green chemistry, that is reduce derivatives. Now coming towards the ninth principle of green chemistry, that is the catalysis. This principle states that using catalyst to make chemical reactions more efficient, selective, and environmental friendly. Basically, this principle emphasizes on reducing energy consumption by enabling reactions under milder condition, increasing reaction selectivity, which reduces unwanted byproducts, minimizing waste by avoiding stoichiometric reagents, improving overall efficiency of the chemical processes, using catalytic system, heterogeneous, homogeneous, or the biocatalysis to achieve the sustainability. So these are the main or important points on which the green principle of chemistry emphasizes on. Right? So now, the importance of the ninth principle is it increases the efficiency of the chemical reaction. It enhances the speed and effectiveness of the chemical processes. It reduces the waste and pollution in the chemical processes. To environmental cleanliness improves safety. It minimizes risk and hazard in chemical operations. It is cost effective because by using the catalyst, we can operate the chemical reactions at comparatively lower temperature and pressure conditions. Sustainability, it promotes the environmental friendly reactions. For example, enzyme in the drug synthesis or the biocatalysis. Production of the chiral drugs is the best example of the ninth principle of green chemistry. Many drugs must be produced in a specific chiral, that means optically active from form for the effectiveness. So enzymes such as lipase, oxidoreductase, and transaminase selectively converts one enantiomer, producing the desired chiral compound with the high purity. Why it is green? That means why the production of the chiral drug is considered as the following principle of the principle of green chemistry, that is ninth principle. Why it is green? Because enzymes work at room temperature and natural pH, saving energy. They provide excellent selectivity, reducing byproduct and purification steps. They are biodegradable and non-toxic, less use of hazardous chemicals. So the final product is the atorvastatin, that is cholesterol lowering drug, uses an enzymatic step for stereoselective synthesis. Other examples includes catalytic converters in vehicles to reduce carbon monoxide and nitrogen oxide emissions, metal catalyst palladium, platinum, nickel in hydrogenation reactions, acid-base catalyst in the industrial organic synthesis. Now, considering the one example only as to following all the three principles. So this one example is the production of the biodiesel from vegetable oil using a catalytic trans-esterification process. So in this process, by using the sunflower seed oil, using methanol and the catalyst, by trans-esterification reaction, we generate the crude biodiesel, and by refining of these crude biodiesel, we can get the pure biodiesel from biodiesel and glycerin as the byproduct. So how it follows the three principles, seventh, eighth, and ninth principle of green chemistry. So let us take one by one. Use renewable feedstock. We know the sunflower seed oil is the vegetable oil. So this is considered as the renewable feedstock. So by using this sunflower seed oil as a raw material to generate the biodiesel, we are following the seventh principle of green chemistry. Reduce derivatives. That is the eighth principle. In this flow diagram, we can easily see that no multiple steps involved in this reaction, only the trans-esterification reaction is there. That is the basic reaction. So this is the one step synthesis of the biodiesel. So it is following the eighth principle, that is reduce derivatives. Ninth principle is the use of catalysis. So by using the catalyst with the methanol, we can generate the biodiesel in the one step. So this is the single example by which we can emphasize the ninth, seventh, and the eighth principle of the green chemistry. I hope all the three principles are clear now. Now, time for the learning check. Please read the question displaying on your screen. The principle reduce derivative, that is the eighth principle, mainly aims to A. Use more chemical steps to improve product purity. B. Avoid unnecessary modifications like protecting groups. C. Increase the use of additives and stabilizers. And D. Increase the number of intermediates. Think the answer of this question. Yes, you are right. B is the correct option, that is avoid unnecessary modifications like protecting groups, because eighth principle focuses on the reduction of the derivative. That means it focuses on the reduction in the multi-step synthesis. So B is the correct option. Thank you. For more videos on the green chemistry, please like and subscribe the channel, and you can go through my channel to view the more lectures on the green chemistry, water, fuel, lubricants, cements, etc. Thank you so much.